Hi everyone, and welcome to this quick little video on linear recursion relationships. Now this probably sounds incredibly difficult and incredibly complicated, but I promise you it isn't. It's very, very simple, and in fact you've actually been exposed to this type of work as early as probably year 7 or 8, but it's been called a different thing and it's obviously been a little bit easier. What we're looking at here is basically finding a pattern. So if I gave you a couple of numbers, for example 1, 4, 7, and 10, I ask you to find the next missing number. This is what this type of work is about. You're using a formula that looks fairly complicated and fairly confusing, but you're using that formula to find a pattern of numbers, a series of numbers or terms. Okay, so we're following a rule, that's all we're doing. In this example here that we have, the next number obviously is the number 13. And how do we know that? Well, we know that the difference between each one is just plus 3. You're just adding 3 from one number to the next. Okay? That's all we're doing. So what we'll be learning to do in chapter 2D here, or today, is how to use a specific formula to find the first 5 or 6 terms in a recurrence relation, which is just a pattern of numbers, a series of numbers. And eventually what you can do, you can actually investigate the relationship between two variables, for example x and y, and you can have a look at and compare them. Okay, so let's get going and let's have a look at how we do this sort of thing. So first of all, what we need to know is the general formula for these linear recursion relationships, the general formula to working out the sequence of numbers. That's what it looks like there. Now the things that you need to be aware of, or the things that you need to know about before we go into an example, is that this A over here on the side, this is the first number. This is our first term in a sequence. So I'll write that down, first term. That's the first number in a sequence. So they will tell you exactly what the first number in the sequence will be. Okay? Then when we look to the D over here, this will tell you how much you need to add to the previous number in the sequence to get the next number in the sequence. Now again, I'll say that again just to make sure that you get it. What our D is, it represents the number that you need to add to a certain number to get the next number in the sequence, and we'll have a look at an example in just a moment using this formula. Now just so you know, this particular formula doesn't have to have the T everywhere, if I can circle it properly. It doesn't have to have the T's there. This is just the general formula. Sometimes you'll see it written with X's, so xn equals xn minus 1 plus D. The D stays the same, and the A stays the same. So it can look something like that with X's instead of T's. It can have B's, it can have A's, it can have whatever letter the question wants it to have. But the general formula will always look like the one on top here, this one here. Okay? So let's have a look at a quick example how to find the first 4 terms of a recurrence relation or a series of numbers using this formula here, using this relation. So again, like I said, it looks similar to the general formula, except that you have T's instead of N, you have X's, sorry, instead of T's, my mistake, and the D's here and your A will actually be a certain number. Okay, so it won't just be D or A. So just by looking at this recurrence relation, just looking at this formula here, what we can see from it straight away is that the first number, remember this is our XO in this case, or TO, the very first number in the sequence will be 6. So what we need to do, we need to rewrite that whole equation again, and we can do that on the side here. So we have xn equals xn minus 1 plus 2, comma, x0 is equal to 6. So that's our relation that we're looking at. The very first thing that we need to do, and I'll write this in red, the very first thing that we need to do is substitute n equals to 1 into your equation. or into your relation, sorry. So that's the very first thing. So whenever you see an n, substitute it with a 1. So this becomes now x1 equals to x1 minus 1 plus 2, and we can leave it at that for the moment. The xi we can bring in a second. Now we have actual numbers, we can actually work this out. But before we do that, we need to substitute our 6. So we have the x0 equals to 6 there. We need to substitute that into our equation. So if we work that out going on from there, we have x1, which means that our first number is equal to x0. And why do I get 0? Because 1 minus 1 is 0. Okay? So I have x0 plus 2. I just continue on my equation. So the next thing I need to do is substitute x0 as 6. Okay, so whenever I see an x0, I need to substitute that with a 6. So what I have left, basically going on from there, is 6 plus 2. So going over that again, the x0, I've substituted with a 6. Okay, and finally, we can all work out the 6 plus 2 gives us 8. So we know now that the second number is an 8 in our sequence. The first number we knew from up here where it said x0 equals to 6, we know that that's the first term in our sequence. The first term in our sequence is 6. And the second term, which is labelled as x1, so x1 is equal to 8. The second number in our sequence is equal to 8. Now all we need to do is keep going from that. The next step that we have, so the next thing that we need to do, we need to substitute, if I just draw a quick little squiggly line going down, the next thing that I need to substitute, or do, is substitute n equals to 2 into my equation. Okay, so whenever I see an n in the equation at the top here, I put a 2 in. So what we have now is x2 is equal to x2 minus 1 plus 2. Okay, so all I've done, instead of n's, I've substituted with the number 2 in that. So now I just simply work it out from there. So what I have, if I choose the right colour, I have x2 is equal to x, what do we have? 2 minus 1 is equal to 1. So we have x1 and plus 2 because we haven't done anything to that part of the equation. Now this tricky part, well, it's not that tricky actually, but what we need to do next is find this x1. Where did I work out what x1 was equal to? Because we need to substitute that x1 with an actual number to find the next number in my sequence. So I need to go back to my working out, and I see that x1 I worked out here in the first part, and we said that x1 is equal to 8. So I need to now substitute x1 equals to 8. So then I continue my working out. I have x2 equals 8 plus 2. And if we get our calculators out and work this one out, we can see that x2 is equal to 10. And I can write that in there. So x2 is equal to 10. So what that means now is that the third number in my sequence, remember the first number in my sequence was the 6 because xo equals to 6 at the top here. The second number in my sequence was the 8, that's what we worked out. Now the third number in my sequence is equal to 10. Can we see a pattern forming? I hope so. Let's work out using the same method. Let's keep going and find our fourth term using the same thing. So again, what I need to do, I've substituted n equals to 1, I've substituted n equals to 2. The next thing that I need to do is substitute, you guessed it, n equals to 3 into my equation. Okay, so whenever I see an n, I put a 3 instead of that n. So what I have left is x3 is equal to x3 minus 1 plus 2. It's getting a little bit squishy, I apologize for that. So all I need to do now is actually work out what I have left. So if I have x3 is equal to x, and 3 minus 1, which comes from the top here, 3 minus 1 is 2, plus 2. Okay, next thing I got to do is find this x2. Where did I work out what x2 was? Well, I actually worked it out right here. That's x2, so I can substitute. I know that x2 is equal to 10. So if I continue my working out, x3 is equal to 10. That's in the place of the x2 plus 2. Okay, so hopefully we can all see that x3 now is equal to 12. So how many numbers do I have? I have the first number. Let me just change colors here for a second. I have the first number of 6. That's my first number in the sequence. I have the second number of 8, third number, and fourth number in my sequence. So if I wanted to write the first 4 terms of the recurrence relation, I can do it in the corner here squishily, but my first 4 numbers will look something like this: 6, 8, 10, and 12. That would be my final answer. Okay, so let's have a look at one more quick and easy example of this this type of work. Now remember, like I said, girls, these formulas, they kind of look the same, but they have different letters. So in the previous example, we had X's instead of the T's. So you'll see a range of different letters. It doesn't have to be X, or it doesn't have to be T. It can be U or V or B or whatever other letter of the English alphabet. Okay, so don't get confused between them. It all means the same thing. You just have different letters. So in this particular question, they want us to write the first 4 terms of the following recurrence relation. And they give us the relation there. You can see it. It's all written down for you. What we need to do is work out the first 4 terms. So like always, you always start by, let me just write this down, by substituting n equals to 1 into your equation. So whenever you see an n in the equation that they give you, you write in the number 1. Okay, so then you just write that again with n equaling to 1. So you have t1 equals t1 minus 1 plus 6. And just before we move on, one thing I forgot to mention before, we can see from our relation here that the very first number is equal to 1. Okay, so the very first number in our sequence is equal to the number 1. Alrighty. Now it does say TO or T0, but that 0 means that it's the first number in the sequence. So going back to our example here, so we've substituted n equals to 1 into our equation, and that's what we have left. So what we need to do from there is just keep working that out by hand. So what we have left is t1 equals, now we have 1 minus 1 over here, so we need to work that out, so it equals to t0 plus 6. Okay, and the 6 comes from our equation. Now what we need to do is we need to substitute t0 into our equation. So t0 we need to do sub t0 equal to 1. So whenever we see the t0, which is this one here, to, we need to substitute it with a 1. Why? Because up the top here, if we look up the top, t0 is equal to 1. So going back to our equation, we have t1 equals to 1 plus 6. Therefore, t1 is equal to 7, if we get our calculators out. Okay, so we've just worked out the second number in our sequence, and we can circle that there so we have it. So the very first number is equal to 1, so I'll write it first here, the first number in our sequence. The second number is equal to 7. Okay, so let's have a look at working out the next number in our sequence. Let me just draw a line here to separate it out. So what we need to do now, just like we did in the previous example, we've substituted n1 into the equation. The next thing we need to do is substitute n equals to 2 into our equation. Okay, so whenever we see an n in our original equation up the top there in the question, we put the number 2 instead of the letter n. So what we have left is t2 is equal to t2 minus 1 plus 6. Okay, so that's all I've done. Wherever there's an n, I've substituted it with the number 2. So the next thing I do is work out everything that I can. t2 stays the same because I can't do anything with it yet. But what I can change, or what I can work out, is this 2 minus 1 here. So we have t2 minus 1 is 1 plus 6. So, whoops, daisy, my mistake. What I need to work out, or what I need to do now, is substitute t1, this term here, with an actual number. Where did I work out t1? Well, I worked it out just before, I hear you all say. Right there, I worked out what t1 was, so what I need to do is plug that number into my formula. So if I keep going, t2 is equal to 7 plus 6. And therefore, if I work that out, t2 is equal to 13. Okay? So I've worked out this is now my third number in the sequence. Okay, or in the relation. So let's do one more and have a look at how we do this one. So again, first thing I need to do, I've substituted n1, I've substituted n equals to 2. The next thing I need to do is substitute n equals to 3 into my equation. So going back to my original equation there, wherever I see an n, I put the number 3 instead of n. So I have t3 is equal to t3 minus 1 plus 6. And again, I work out whatever I can, and if I look at my equation, I can work out what 3 minus 1 is. So I keep going with my equation. t3 equals 3 minus 1 gives us 2 plus 6. And now I need to have a think about where I worked out what t2 was equal to, because I need to substitute that with an actual number. And where did I do that? Well, I did that in the previous example right there. I know what t2 is equal to, so I can substitute that in. So, t3 is equal to 13 plus 6, and if we work that out, again, t3 is equal to 19. And that's my fourth number in the sequence. Okay, so if I were to give a proper answer for this, what I would do is I would just write the actual numbers one after the other, or I would say something like the first 4 terms are, and then I'd put the numbers, I'd put 1, and what else do we have? 7, 13, and 19. Now hopefully from these first 2 examples you can see a pattern forming, and I'll give you a little hint. Take a look at what the first number is at the top here, this 1. Alright, so that's your first number. And have a look at what the equation actually tells you, that plus 6. Have a look at what happens from there. I'm not going to give it away, that's for you to work out, and I'm sure everyone can do that. You can figure it out on your own, because there is a shortcut to doing this. You don't have to do all of this writing for the one question. Okay, there is a quick little shortcut. Now the next thing I want to talk about is the way that these questions can be made a little bit harder. So, for example, they don't have to give you whole numbers, first of all. They can make TO equal to a half or 3/4 or whatever number they want to. Okay, so then you might need to use a calculator to make sure you get the right numbers there and you don't mess anything up. But also, they can rearrange this equation at the top here. They can rearrange that to equal to whatever they want. Okay, so you might, in some cases, you might have to rearrange the equation a little bit. Okay, just a couple of little hints and a couple of little things that you will encounter in some of the questions. Next little example that we'll be looking at is a worded question. So you'll be getting a lot of worded questions where you just need to be able to pick out the right information that you need to answer the question. So in this example we have, and please excuse my writing, we have the example of a pencil that increases each year in price by 10 cents, and in a certain year the pencil costs us 80 cents. what we need to be able to do is find the price for the next 4 years. This is just an example. You might be given different types of, obviously different types of questions, different numbers, and so on and so forth. So the very first thing that you need to be able to do, we can write this down here, the very first thing that you need to do is actually write down your recurrence relation. Write the general recurrence relation formula, which is Tn equals to Tn minus 1 plus D, and you remember this from the very beginning, comma, T0 equals to A. Okay, that's the very first thing that you need to write down. Second thing that you need to be able to do is tell me what the actual D and A is equal to, and you'll know this and you can find this from the question itself. Okay, so in this case, if we start with D, D is the amount that the pencil goes up every year. So how much does it increase? It goes up by 10 cents every year. Okay, so your D is always the number or the price or whatever else it might be that increases every year or every month or whatever the question might say. So D in this example is equal to 10 and our A is equal to 80. Okay, so that's our first number that we know of in the sequence in this example. We know that at some point in 1 year the pencil cost us 80 cents. Okay, so it doesn't matter when, it doesn't matter how long ago or anything like that, it just matters that we know that that's the first number in our sequence. T0 is equal to 80. Okay, so then what we need to do from there, just like we've done with the other examples, you can forget about the worded question. What you need to know is already written down. You know what D is equal to, you know what A is equal to. What you need to do from there is work it out just like we've done before. So if we write step number 3 here on the side, and we'll just go through the first example finding T1, because the rest I'm sure you can do. So the very first thing that we need to do is substitute, just like before, n equals to 1. So whenever you see an n in your equation, you substitute it with the number 1. So what we have left is T1 equals T1 minus 1, oops, that's an equals, plus, in this case, 10. Okay, because that's what our D is. So what you can do if you want necessarily, you can rewrite the whole equation. If we write the whole equation here underneath with the numbers in it, so Tn equals Tn minus, oops, not equals, minus 1 plus 10, comma, To equals to 80. So you can write that down just to see it, to have it in front of you. So going back to our third step here, what we need to do now is again work out what T1 is equal to. So going on, T1 is equal to, and we can work out what 1 minus 1 is. We know what that is. It equals to 0 plus 10. Where do I know what T0 is equal to? Well, I know it from my equation over here. T0 is equal to 80, so I can plug that, I can substitute that in. T1 is equal to 80 plus 10. So therefore, in the second year, my pencil cost me 90 cents. Okay. Now again, if you figured out from before, or you've had some time to think about what the little trick is and what the shortcut is to work these out, by all means use the shortcut. If not, please keep working it out like this. There's only 4 lines of writing to do for each part. So the next thing you'd have to do, if we go across to step number 4, and I won't actually work this out, but the next thing we had to do is substitute n equals to 2 into your equation. Okay? And you'd go on from there, and eventually you'd work out how much the pencil costs over the 4 years, like the question wants you to work out. Alright, so the last thing that I want to talk about and go through one quick example with you is what can happen if we rearrange our general formula here, our linear recurrence relation formula. If we rearrange that to make it look something like this, Tn minus 1 equals D, and To equals A. So if we rearrange that top formula to make it look like the one in blue there, The new relation is called a linear difference equation. Why is it called a linear difference equation? Well, it shows us the difference between two consecutive terms in a sequence. Don't worry about that. Believe me, that's exactly what it does. So any linear difference equation will have a corresponding linear equation which will be in the form of y equals mx plus c. So anything that has that linear difference equation, the one in blue at the top, this one here, will have a corresponding linear equation that looks like y equals mx plus c. And I'm sure that we've all seen this before, this y equals mx plus c, from year 9 onwards or even year 8 onwards. Okay. Now, if we compare the two formulas in blue, what we have basically, the y is equal to tn, our m is equal to d, and c is equal to a. Oops, that's not an a, that's a d. A, there we go. Okay, so if we compare this y equals mx plus c, the different parts of that formula mean different, or have corresponding terms in the formula above it. So the y is equal to tn, the m is equal to d, and the c is equal to a. Okay, so that we can rearrange this formula. Again, we can write this y equals mx plus c in a different manner, which looks something like this. Tn equals dn plus a. Okay, so again, like I said, the tn comes from there because y equals tn. Instead of m, we write d, and the n just comes from our above equation here, and the a instead of the c, just like that. Okay, so that's where the different parts of the formula come from. Sorry. So this sort of formula, this tn equals dn plus a, which has just come from basically our original equation, our original recurrence. This type of correspondence is useful in solving problems that describe real life situations. Okay, and we'll have a look at a quick example and one more type of question that you'll be getting in this chapter. Okay, so the last thing that we'll look at today in this for this type of work is how to actually find a linear difference equation from some information that we're given, and how to find a linear relation between two different points. So we said at the very, very beginning, if you can remember back, we can actually investigate the relationship between two quantities, so we can see if they are linear or not. Well, this is what it's all come down to. This is what we are doing right now. We will find the linear difference equation between n and tn, and we will find the linear relation between tn and n. So again, we have our table there at the top. That's the information that we're given in the question. The first thing that we have to do, part A says, find the linear difference equation. Okay, so the first thing that we need to do to work out part A, we need to find the difference between each pair of consecutive terms. So again, say that again, we need to find the difference between each pair of consecutive terms. So what that means, we need to take each term or each pair of terms and find the difference between them. So for example, for the very first one, we need to do t1 minus t0. Now if you think back to our general formula or our general recurrence, our recursion relationship, the general formula said that TO is the very first number in a sequence. So TO would actually be this one here. Okay, this will be T1, this will be T2, this will be T3, if I can write properly, and this will be T4. It's not plus 4, it's T4. Okay, so going back to our writing down here, T1 is equal to 3. Sorry, I was just looking at something else. So what we have 3 minus 7. So therefore the difference between the first pairs is going to be negative 4. Okay, and we do this all the way along for all the different pairs. So the next one that we'll be looking at is T2 minus T1, and that brings us to negative 1 minus 3, and that is equal to, you guessed it, negative 4. The next one along I didn't write T1, sorry. The next one along we need to write is T3 minus T2, and that is equal to -5 minus -1. If we do that on a calculator, we'll find that we get to -4 again. And finally, we have T4 minus T3. And the numbers are, and these numbers, just before I move on, sorry guys, the numbers that I'm getting here are from the table. So if we go back to the very beginning here, T1 is T1 in here. Okay, so T1 was 3, TO or T0 was 7. So that's where I'm getting the numbers from the table, just in case some of us are a little bit confused. So going back to our final one here, T4 minus T3, T4 is -9, and T3, so we have minus -5. Write that in a different color. My OCD is kicking in. Anyway, and we get an answer of -4 again. So we can see all the way along there, the difference between them is equal to -4. So it's a constant difference. If it's constant, it means that it actually is linear. So if we were to write this into our equation that is slightly rearranged from what we're used to, we would have something that looks like this. Tn minus Tn minus 1 is equal to -4, where T0 is equal to 7. Okay, so that's our answer for the very first part, to find our linear difference equation. That's our answer there. And we can see that instead of T4, this will be our D here, and that will be A. Okay, so that's all we've done there. We've just substituted those different parts in. Let's have a look at part B now. Part B, again, we need to start off with the equation that we just wrote down. So Tn minus 1 is equal to -4, where TO is equal to 7. So the first thing that we need to do is write down the linear difference equation that we worked out in part A. Now, to get the linear relation between Tn and n, what we need to do is work out or write down the general form of the linear relation, which looks something like this, and we looked at it just before. Tn is equal to dn plus a, and that should look similar, or familiar, sorry, not similar, familiar, because it's basically the same thing as saying y equals mx plus c. Okay? And then all we need to do, if we move along to some free space over here, all we need to do is substitute the numbers into the correct part of that second formula there. So we said that the -4 represents our D and the 7 represents A. Okay, so that's what we said before. So all we need to do into the formula, into this formula here, we need to substitute those numbers. So what we have left as a final answer is Tn equals to -4n plus 7. And that there will be our final answer, and that's our linear relation between Tn and n. Now again, you'll get questions like that look like this, but you'll have different numbers. They'll ask you to do the same thing. First of all, in part A, all we did was we worked out what D is equal to. So if we go back to part A here in the question for a second, we can say that D is equal to -4, right? That's what we worked out. And then in part B, we actually substituted those numbers into the linear relation between Tn and A. Remember, girls, that you can always go back and re-watch the video, pause, rewind if you get confused at any parts. Let me know if you have any questions. Have a go at the questions in your book, and good luck, girls.